Hey folks, today's topic is evaluating logarithms. So last time we spent a little bit of time talking about logarithms, and we talked about them in terms of exponentials. So I want to get into a little bit more detail of what is this thing called a logarithm. So let's look at this example where I have two different styles of equations. So I have x to the second equals 32 and 2 to the x equals 32. How we solve these is very different. So in this case, we feel probably pretty comfortable with solving x squared equals 32. What kills squared? Square root. Square root is on file. We don't need no water. We just need a plus or minus. Now, square root of 32 is something that you can clean up. I'm not going to get into that right now. Just remember that you'd break it into 16 times 2. The 16 escape becomes a 4. I want to talk more about how do we handle this scenario. So you see both of these have an x with a 2, but where that x is totally different in one versus in the first example versus the second. So as I'm looking at this, I'm trying to kill the squared and the undo squared with square root. Well, this isn't squared. This is 2 to the x. So square root won't work here. We'd have to do something called an x root, which there is no such thing as an x root, at least not that I know of. So we can't undo that x. Plus, if we got rid of the x, then we wouldn't have there'd be a mess. I'm just going to stop there. So what is this thing that we do that kills 2 to the? So this is read x to the 2. This is, I'm going to say it as to the, 2 to the x. That's where this thing called log comes in. Log base 2, log base 2. So just like over here, we did square root on both sides to kill off squared. To kill off 2 to the is this thing called log base 2. Now, they don't have a cool symbol for it. They just have this symbol, or they just write the word log with what base they're going to do. So there's not really, it's not as nice as the root symbol is, but it's the same idea. This log base 2 is around 2 to the. So what happens is the log base 2 and the 2 to the cancel each other out, just like the square root and the squared cancel each other out. So the squared and the square root undo each other, so you're left with x. Log base 2 and 2 to the undo each other, so we're left with x. Now, over here, we have kind of a mess. Same thing over here. We have this now log base 2 of 32 thing, which we're going to try to figure out what does that even mean. So let's do that now. Now that we have hopefully have the idea of what a log is, just this thing that undoes to the, let's talk about how to manage evaluating these operations. So there's two different formats. This is the same as this. So in other words, what we can do is we can take something in this form and convert it into this form. Now, I like this form a lot better because what doesn't it have? It doesn't have a log anymore. So basically what we're doing here is all we're doing to convert this into this is we're going b to the and b to the. So we raise both those sides to b. The b and the log base, the b to the and the log base b cancel each other out. That's where they get the m, and then b to the n is on the other side. Now, I'm not going to solve it that way, but I'm going to think about it that way. All right, so let's take a look at one. So I want to start off here, log base 2 of 32. I don't know what this answer is, but I do know it's some number. So I'm just going to say that equals n. Now I'm going to go from logarithmic form. See how this is in logarithmic form? Log base 2, log base b of m is 32, equals some number. And I'm going to convert it into exponential form. Another way to think about this is kill off log base 2 with a 2 to the. So now I have the statement 32 equals 2 to the n. Now this is something I could manage. I probably can't do it in my head, but I can grab my calc at this point and I can start to play around. With 2 to the until I get an answer of 32. So 2 to the, I don't know, third? No. 2 to the 7th? No. 2 to the 5th? Yeah, there it is. So 2 to the 5th. So this is saying 2 to the what is equal to 32. We just figured out that 2 to the 5th was 32. So 5 is our answer. So log base 2 of 32 is basically saying 2 to what number would give me an answer of 32. 2 to the 5th would give me that answer. All right, let's try another one. If you need to rewrite it, great. If you don't, I'm fine with that too, but I'm going to initially rewrite it. I'm going to say, I know this equals some number. So this is asking me 4 to what number would give me an answer of 256. So I'm going to rewrite it like that. And mathematically, algebraically, what I'm doing is I'm going 4 to the over here and 4 to the over here. Now 4 to the and log base 4 cancel each other out, so I'm left with 256. And then 4 to the n is 4 to the n. At this point, I can mess around with my calculator. 4 to the 4th. Yep, I got it. One try. 4 to the 4th is 256. So 4 to the 4 would be my answer. Log base 4 of 256 is just 4. I'm going to encourage you to pause and try to do the next one. All right, let's see how you did. This equals some number. I'm going to 7 to the both sides, so I get 16,807 is equal 7 to the n. Grab my calc. 7 to the 5th. So I get an answer of 5. All right, now we're going to look at some tricks. So we hopefully have the basics down. Where are the things that we could get mixed up or get caught on? So let's look at the first one. Equals some number. 8 to the, so 1 is equal to 8 to the n. Now, the first trick is anything to the that ends up as a 1, that to the has to be 0. Anything to the 0th power always ends up being 1. So that's my first hint, dead giveaway. If you're trying to create a 1 with a to the, just make it 0, game over. All right, next up. This is where things start to get a little bit messed up, where your base is actually bigger than the number that you're trying to evaluate. So I'm going to say this is equal to some number. I'm going to do the rewrite. So 2187 to the both sides. So 3 equals 2187 to the n. Now what's so confusing about this is right away 2187 to the 0th is 1. 2187 to the 1st is 2187. So we went from 0 to 2,187. We skipped 3 altogether. So that means our answer has to be somewhere between 0 and 1. So it's going to be some sort of fractional scenario. So this is how I did it. And how you think about it can be your own, but this is the way I recommend it. My goal is to turn 2,187 into 3. Now that's really hard to do. That's difficult to turn a bigger number into a smaller number. So I'm going to think the other way to give myself a hint. What does it take to turn 3 into 2187? So 3 to the 7th ends up giving me 2187. So 3 to the 7th ends up being 2187. So that means, what would I have to do to 2187 to turn it back into a 3? In other words, what undoes 7th exponent? That would be a 7th root. Now look, I can't write this as a root. It has to be an exponent. It has to be 2187 to the power of, not the root of. But we talked about this earlier. There is a way to write a root as a fraction. So just a quick reminder. Let's do the easy one first. Square root of x is equal to x to the what? 1/2. Cube root of x is equal to x to the 1/3. Do you remember this trick? So that means we can then make a statement that says the nth root of x is equal to x to the 1 over n. In other words, fractional exponents are the same as roots. So coming back to this example, I want to do 2187 getting 7th rooted. Well, what exponent is the same as the 7th root? That would be to the 1/7. Let's have you pause and try to do example 7. You're probably not ready for it yet, but let's just see how you do. All right, let's take a look. So we have, first I'm going to do my rewrite. This is equal to some number. So 6 is equal to 216 to some number. Now, because 216 is bigger than 6, my goal is to turn 216 into 6. But because this is bigger than that, that's pretty tough to do. So I'm going to use this direction to help me get a hint. 6 to the what ends up being 2016. And we find out quickly that that's the same as 6 to the third. Well, if 6 to the third is 216, then 216 cube rooted is 6. Well, we can't have cube root be our answer. Cube root has to be converted into its fractional exponent. So cube root is the same as to the power of 1/3. So our first idea, we started off with just kind of introducing how to evaluate any sort of logs. Our first trick was if your answer is 1, anything to the 0 is 1. Then we got into fractional exponents, a reminder that if you want to do a root, that's the same as to the 1/3. So 216 to the 1/3 is the same as the cube root of 216. The next trick comes when you're looking at something on the bottom. So I want this to equal some number. So when I do my rewrite, it's going to be 5 to the and 5 to the. So 1 over 125 equals 5 to the some number. Now, turning 5 into a fraction is very hard to do. But turning 5 into 125 isn't that hard to do. I want to turn 5 into 1 over 125. That's tough to do. Let's start off. Here we go again, trying to find a hint. Let's find out what 5 to the equals 125. And so we quickly learn that 5 to the third is the same as 125. But what did we learn a couple of units ago about negative exponents? What do negative exponents mean? Flip. So if I go 5 to the negative 3, it's going to take that 125 and reciprocal it or flip it over. So my answer is going to be not 3, but negative 3. 5 to the third makes the 125. 5 to the negative third takes that and reciprocals it. So let's add that to our little chart up here. What would be a good color? I guess I'll go with purple. Let's go with the red. So 1 over x to the n is the same as x to the negative n, or in other words, negative exponents equal a fraction. So if I want a fraction, then I need to have a negative exponent to get me to that spot. So let's have you try to do, which ones can you do? You could probably do, you could probably do the rest of these. Oh, no. You can't do example. Let's do one more together. This one's sneaky. So here we go again. I'm going to first set up this equals some number. So when I do my rewrite, 36 equals 216 to the n. So here we are in this spot where 216 to the 0 is 1, 216 to the first is 216, so we skipped 36 altogether. So this is going to be some sort of fractional exponent. The problem is if I go the other direction and I start with 36, so like over here, remember we started with 6 to try to build 216, and that gave us a clue on how to work backwards. In this case, if I go 36 to the first, That's 36, which is smaller than 216. And 36 to the second is 1296, which is bigger than 216. So when you have a situation where neither of the numbers go directly into each other, you have to find another number that goes into both of them. So now we're thinking about this in terms of exponents. So I can't say the number 2, even though these are both even. 2 to the will not generate either one of these. But what number to the would generate a 36 and generate a 216? Well, turns out the number 6 is a good choice. So I'm going to take 216, I'm going to turn it into 6. I'm going to take 6 then, and I'm going to turn it into 36. Now, turning 216 into 6 is tough to do, so I'm going to work in reverse. I'm going to think backwards here to try to help myself thinking forward. So what would it take to turn 6 into 216? 6 into 216, I would need to cube it. 6 cubed is 216. So 216 to the what would turn into 6 to the 1/3, because that's the same as cube root, right? So if I go 216 to the 1/3, that would make it into a 6, but I don't want a 6, I want a 36. So 6 to the what would make a 36, 6 squared would make a 36, and then I'm going to take those two together. 1/3 times 2/3 ends up being 2/3. Now remember, you can always just check these to see if they work. 216 to the 2/3, 36, which is what I wanted to do at the beginning. So when you can't find an easy path, try to find another number that you can sort of use as a stopping ground to go in between the other two. So I'm going to encourage you to pause and try to do all of these. And then but you can check them as you're going through, of course. All right, let's see how you did. So pause if you haven't yet, give them a try. So I'm going to do a rewrite. So 7 is equal to 343 to the n. I can't go this direct. I can't turn 343 into 7 very easily, so I'm going to turn 7 into 343. 7 into 343, 7 cubed. But I don't want to go that direction. I want to go the other direction, so that means I would have to cube root. So then that's going to give me, what, 1/3? And like I said, you can always check. Ends up being 7. So when I rewrite this, 64 is equal to 4 to the n. That's one we can just do in our calc. 4 to the 3rd, I think. Yep. 4 to the 3rd is 3. All right, these are one of those fraction ones, so I know I'm going to need a negative exponent along the way. So 1 over 1296 is equal to 6 to the something. 6 into 1296 would be 6 to the 4th. 6 to the 4th is 1296. Now, do I want to go the other direction, or do I want to reciprocal or flip? I want to flip. So that's not going to be a 4. It's going to be a negative 4, which is going to take that 1296 and flip it over. All right, so I would go to the, so 1/8 equals 64 to the something. All right, turning 64 into 8 is hard to do. So I'm going to start with 8. I'm going to turn it into 64 first. So 64 into 8. That's actually not too bad. I could probably do that one. I'm going to go the other way, though. All right, so 64 to the second ends up being 64 to the second ends up being, let me try again. 8 to the second is the same as 64. So 64 to the 1/2 would be 8. The problem is I don't want this to just be 8. I want it to be 1 over 8. So to the 1/2 would turn the 64 into the 8, but then I want to reciprocal that or flip it over. So not only do I need the 1/2 to make it into a smaller number, I also need the negative to flip it. And then lastly, so I want to turn 625 equals 3125 to the n. So can I do just 625? What's that to the second? Yeah, that's already way bigger. So I've got to find something in between. Some sort of exponent that makes something to the, that makes a 625 and a 325. That 5 is a hint to me. 5 to the third, 5 to the fourth. Okay, 5 to the fourth. Let's try to the seventh. Nope, too big. So 5 to the fourth and 5 to the fifth. 5 to the fourth and 5 to the fifth. So I'm going to try to break this down. I'm going to start at 3125. I want to turn that into a 5, and then I'm going to take the 5 and turn it into a 625. All right. Now, turning a 3125 into a 5 is not easy. Turning a 5 into a 3125 is, so that's 5 to the fifth, which means if I want to go this way, I need to do a fifth root. And then I typed that in already. Was it 5 to the 4? Yeah, 5 to the fourth ends up being 625. So now I'm going to multiply these two because I want to do them both at the same time. So I get 4/5. Oh, man. Should have done that in yellow, not purple. This was not a purple problem. It was a yellow problem. The purple was just my notes. How embarrassing. All right, not so easy. Not easy. But what's nice is you can always check these. Like just a reminder, I can always check. 3125 to the 4/5 should to the 4/5. 3125 to the 4/5 should give me a 625. Yep. So you can always check. Might take a little bit of work to get there, but the big takeaway I'm hoping is that you're thinking about things in terms of roots are fractional exponents and negative exponents mean reciprocal. Good luck.